Hello class, today we'll be talking about 11.4 fundamentals of probability. So in this section, we're going to compute theoretical probability and we're going to compute empirical probability. So when we think about probability, we have ranges from 0% to 100%. So 0 would be impossible, 50% would be 50-50 chance, and 100% would be certain. Or we can look at it as 0, 1/2, or 1. So where 0 is impossible, 1/2 is 50-50, and 1 is certain. So when you find your probabilities, usually you get a number between 0 and 1. So pretty much the closer you get to 0, the less likely it will happen. The closer you get to 1, the more likely it will happen. So theoretical probability. Experiment is any occurrence for which the outcome is uncertain. The sample space is any set of all possible outcomes of an experiment denoted by S. An event denoted by E is any subset of the sample space. Sum of the theoretical probabilities of all possible outcomes is 1. So when you add up all the probabilities, they should add up to be 1. Now, computing theoretical probability. It says the probability of E of the event happening is equal to the number of outcomes in event E over the total number of possible outcomes in the sample. So that's why it says N sub E and N sub S. So it's the number of outcomes in the event over the number of outcomes in the sample. And that's what we denote it by. So we're going to use this. So it says a die is rolled once. Find the probability of rolling a 3. So first we need to figure out what our actual sample space is. So our sample is denoted by S. So on a die you have what? 6 sides. So you can either roll 1, 2, 3, 4, 5, or 6. Now, the event says that we're doing what? We're rolling a 3. Now, since we're only using one die, we only got one way we can roll a 3. So, when we look at N sub S and N sub E, we have 6 things in the sample and 1 thing in the what? Event. So, the probability of E happening is equal to 1 over 6. So make sure when you look at this, now, you probably was like, oh, I figured that out from the beginning. Yes, it's easy to figure out without having to write it out, but sometimes you have to write out the whole set because it may not be as easy as just looking at it and saying, oh, it's 6-sided. It's only 1 3 on one side, so it's 1 out of 6 chances. Now, what about an even number? The sample is still the same, but so our N sub S is still 6. What about an N sub E? Now, what we can look at, the event in this case would be what? 2, 4, and 6. Because the number is what? An even number. So the number in our event would be 3. So the probability of rolling a even number is what? 3 over 6, which is equal to 1/2. So let's look. Let's look at some more examples. It says you are dealt 1 card from a standard 52 card deck. Find the probability of being dealt a king. Now, it tells you what your S is. So, or your N of S. Well, we know it's 52. Now, we have to figure out what your N of E is. Now, in a standard 52 card deck, you should have 4 different suits which is hearts, diamonds, clubs, and spades. Therefore, each suit has a king. So it's 4 different suits, so there are 4 different kings. Therefore, when we find the probability of this happening, it'll just be 4 over 52, which that reduces to what? 1 over 13. Now, if you don't know what a standard 52 card deck is, they do have an example of it in the book for all the different suits and everything that's in the suits. Now, what about the probability of being dealt a heart? Now, we know that the N of S is what, 52? Now, if we know that we have 4 different suits, all right, and we know we have 52 cards, we can divide what? 4 into 52 and get what? We'll get 13. So therefore, it's 13 hearts in a deck. So when we find the probability of this, we'll have what? 13 over 52, which equals what? 1 over 4. Now, like I said, they have all the cards laid out in your book. If you go to this section, 11.4, they have all the cards laid out in the book. Now, make sure if you have any questions about this, you make sure you send me a message through Microsoft Teams or you send me an email. So let's look. Empirical probability implies the situations in which we observe how frequently an event occurs. It says computing empirical probability, the empirical probability of the event E is the probability of E is equal to the observed number of times E occurs over the total number of occurrences. So if we look at this, it's basically, when we do empirical probability, it's something that somebody had actually set and went through the process. They observed flipping a coin 100 times and calculated and basically counted how many times it landed on heads or tails. So let's look at this example of empirical probability. Now, empirical probability usually have tables, or it tells you how many times something happened. So it says if one person is randomly selected from a population described above, find the probability that the person is a woman or a female. So let's look at this. Now, we have to keep in mind to figure out what the total number is. So the number in the sample would be 242. Now, the number in the event, which is the number of women, now, it doesn't matter if she's married, never been married, divorced, or widowed. So the total number of women would be 124. So when we look at the probability of this happening, we have 124 all over 242. Now, we can reduce this or just write it, or go and write it in decimal form. It's approximately what? 0.51. It's approximately. So roughly about what? 51%. 51% is what? Women. Out of the data that was given. Now, make sure if you have any questions about this, you send me a message through Microsoft Teams or you send me an email.